Um, Good day, everyone. Welcome once again to our online Tech Talk series brought by TechVas Global. My name is Salako Fatia, and I hope we are all doing great and you are ready for today's discussion. So, in the last session, Mr. Abdulaziz Lawal, he walked us through breaking into tech, the rise of agentic AI, in which he highlighted that the brain behind AI systems are LLMs, and he showed us how LLMs and AI agents are getting smarter and how they are handling tasks on their own. So, just in case you missed last session, you actually missed a lot, and you can go to TechVerse YouTube page and walk through and check for the video for the last session, which is breaking into tech, the rise of agentic AI. So, one thing Mr. Abdulaziz actually emphasized on is the importance of quality data sets. So, because without well-structured data, LLMs, which are large language models, and AI agents, they would have nothing to learn from, and those systems just wouldn't work. And that was what brought us to today's topic, which is what is a database and why do we use it? So just like we said earlier, that LLMs are the brain behind AI systems. So how do we get these LLMs? LLMs are trained on large data sets, and without data sets, there won't be LLM, and without LLM, there won't be AI agents. So that shows that okay, data sets are actually important, and invariably, either is AI systems or LLMs, they depend on data sets. So and we'll be talking about data sets, what data sets really are, and why do they matter so much in tech, and how do they help us manage information that powers softwares, apps, and even AI systems? So to guide us through this interesting topic, we have a special guest who is a talented front-end developer and is currently on his learning path to React. And he also builds websites. And when he's not working, he probably when he's not like when he's not building websites or probably writing codes, is probably you can find him gaming or enjoying a football, probably a football match or something. So we all have something we do during our leisure time. So let's welcome Mr. Abdulmalik to the stage.
Okay, thank you, Miss Fatia. Can you hear me?
Yes, I can.
Okay, I'm really excited to be here today to talk about something that is behind almost every app, website, or online services we use. You might not see them, but they are working. When you wake up every morning and go on your WhatsApp, maybe you want to check your message, you might be wondering where your messages are stored, where are they coming from, where if they hit them, where they go to. There's something working behind it, and there's something with security working behind. That's what we call a database. By the end of this talk, you understand what a database is, why we use it, how it keeps things reliable, and how we make sure we don't lose data, even if something goes wrong. Okay. Let's start with a simple question. What exactly is a database? Think of a database like as a super organized digital filing cabinet or a library, or um, and instead of keeping papers in messy piles, all your information is stored in an orderly way so you can find them easily. For example, imagine an e-commerce website where thousands of products, millions of users, and countless orders are placed. Without a database, keeping track of all this will be very impossible. You have to remember every customer, every product, and every transaction you make every day, which is clearly not clearly impossible. Okay. Why do we use database? To start, we use database to store large amounts of data efficiently, to allow many people to access and use the data at the same time, to keep data accurate and reliable, even when multiple people are making changes. We also use database to quickly retrieve information when needed. So not all databases are the same. Depending on the type of data and how it's used, different databases exist. Okay, let me explain with simple analogies. Okay, the first one we're talking about is the relational database. That is the RDBMS, which is also known as Relational Database Management. Data are stored in rows and columns, and you can easily find relationships between different tables. Examples of relational database are MySQL and Oracle. Programmers uses a language called SQL to ask questions from these databases, like show all orders from last month. Okay. You also have no SQL database. That is the opposite of relational database. These are like digital notebooks or document collections. They are flexible and can store unstructured data like posts, comments, videos, or any other things you do on social media or stuff like that. Examples are MongoDB and Cassandra. Okay, the third type of database we're talking about is in-memory database. This store data in RAM, not on disk, which makes access super fast. Examples are Nimashed, used for caching or real-time applications. Okay, there's also distributed databases. These spread data across multiple servers or locations. This helps apps scale to millions of users without slowing them. So depending on the problem you are solving, you choose the database type that works best. Now, let's talk about something that makes databases reliable, the ACID properties, ACID properties, which is also known as ACID stands for atomicity, consistency, isolation, and durability. These are the rules that keep your data safe and reliable. Let me break them down with an example. Imagine you are transferring money from your bank account to a friend's account. Atomicity. This means a transaction is all or nothing. Either the money leaves your account or reaches your friend's account, or it doesn't happen at all. You don't want a scenario where the money leaves your account but never reaches your friend. Consistency. This ensures that the database always stays correct. Okay. For example, the total money in the bank shouldn't change. It just moves from your account to your friends. So this allows won't there won't be any thing blocking the block part, anything blocking the part where your money should go to your friend's account. So the third one, isolation. This keeps transactions independent. If two people are booking the last seat on a flight at the same time, the database ensures only one booking succeeds. So, so this means that two people can book a seat at the same time. Durability. Once a transaction is complete, it's permanent. Even if the system crashes immediately after you pay for a product, the record of your payment will still exist. Even if you cancel the transaction, the payment will still be there. Okay, without assets, data could be lost, duplicated, or corrupted, which could be catastrophic in banking, healthcare, or e-commerce. Even for non-programmers, the takeaway is database don't just store data, they protect it and ensure it's trustworthy. Even with asset properties, things can go wrong. Servers crash, disk fails, or human makes mistakes. This is why database backup and recovery is essential. Let's look at two common backup methods. One, we have the full backup method. Imagine photocopying an entire book. That is the full backup. You have a complete copy of your data. This is very easy to restore since everything is in one place. And the disadvantage of this is it can take a lot of time and storage, especially for large databases, especially for the schools. Imagine storing a lot of students on students' copies, results, and everything on um, one database. It can take a lot of time and storage. Incremental backup. Instead of copying the whole book every time, you only copy the pages that changed since the last backup. The advantage of this is that it is much faster and uses less storage. Disadvantage is its recovery is slower because you need the last full backup plus all the incremental backups. Okay. Always test your backup to ensure you can restore them. Automate backup whenever possible to avoid human errors. Backup and recovery are like insurance for your data. You hope you never need it, but when disaster strikes, it's the only thing that will see you. Okay, databases are everywhere in banks, e-commerce, social media, healthcare. In banks, we use databases to track accounts, transactions, loans, open accounts, and different kind of stuff like that. In e-commerce, we use database to keep product catalog, orders, and payments organized. Social media, we use to store posts, messages, like, comments, reels, video, and all that. In healthcare, we use it to manage patients' records, prescriptions, and appointments. Without databases, none of this system would work reliably. Every time you use an app, a database is silently and working anonymously in the background, making it possible. Okay. Mm, okay. In database, programmers use database. There's what you call programmers call CRUD operation. Programmers create, that is what you call create, read, update, and delete. Programmers use database for that. So to summarize, a database is a structured place to store, manage, and retrieve data efficiently. ACID properties, that is the asset properties, ensure transactions are reliable and data stays correct. Backup and recovery protect us against unexpected failures. Databases power nearly all modern technology, from banking to social media to school and the likes. Whether you're a programmer, a student, or just a user of technology, understanding how databases work helps you appreciate the invisible backbone of modern application. Thank you for listening.
Mr. Abdulmalik, thank you very much for taking us through the importance of database, what they what they are using for in tech, and there are various applications. But I have a question. You mentioned the ACID properties, but I couldn't get what is A, what is C, what is I, and what is D. Is an abbreviation, right? So can you take us through like the what ACID really is, and why is it really important in a database? Is it that we need to is it like it is a requirement for creating a database, or probably after the database has been created, it's probably what we would use to sustain and maintain it? So please, can you take us through that again? Thank you very much.
Okay, the acid properties stands for atomicity, consistency, isolation, and durability. Okay, these are the rules they are just the rules that keep your data safe and reliable. Atomicity is transaction is all or nothing. Consistency ensures that the database always stays correct. Isolation keeps transactions independent, and durability, once a transaction is complete, is permanent. Even if the system crash after you pay your product, the record of your payment will still exist. Okay, that's
Okay. So the data sets, how do we get data sets? Like, where do they originate from? Is it that they are gotten from the web, or probably it's created from somewhere, or it's scrapped or something? Sha, can you just take us through why where we can get data sets? And please, can you just brief? It's probably like a minute, so just round up.
okay. The data set is a collection, like collection of reload related data grouped together for analysis, storage, or processing. A data set is like a single file for storage of information inside a database. For example, in the classroom mark sheet, data set is like a mark sheet. Each row has one student, columns as name, subject, marks. The whole mark sheet is a data set. Okay, that will be all for today, for today's session. Thank you and have a nice day.